Alright, so here I am at Elyria High trying to figure out how I can use the law of conservation of momentum to answer this question, where we know that I've got a hockey player from the Mighty Ducks, from the not very interesting movie Mighty Ducks 2, a hockey player from the Mighty Ducks and a hockey player from the opposing team from Iceland are coming towards each other, and they're going to grab onto each other because that's what hockey players do. And I'm going to use my knowledge of what the two hockey players were doing before they ran into each other to figure out how they move up after the two collide with one another. So the first thing that I think I want to do to answer this is I'm going to just draw out a quick sketch of before versus after, because for me that helps me sort out what momenta I'm looking at, what velocities I'm looking at, makes me get my directions right. And we can often make mistakes by not being careful about our choice for direction when we work with momentum. So, like I said, the first thing I'm going to do is just make a quick sketch of comparing before versus after. And beforehand, I've got, here's a hockey player, I'll give him some skates. Here's a hockey player, that's my duck. And he's moving 4 meters per second, and there's nothing in the question that makes me draw him moving to the right. I just did because I have to pick one way or another. And now the other hockey player from the other team is going to be coming in the other direction. That hockey player is coming in the other direction, and reading the question tells me that that hockey player is moving at 3 meters per second before. That's the enemy player. So these two are coming towards one another, and I'm going to compare their total momentum before they collide versus after they collide. I'm thinking right now, looking at this, I probably want to choose which way my forwards, my positive direction is, just so I'm consistent from the start. And I don't see any reason why not to. I'm just going to make going to the right is going to be my positive direction. So that's going to mean that the Mighty Duck is going to start with a positive amount of momentum, and the player from the other team is going to start with a negative amount of momentum. Now, after they crash, then I'll be looking at these two players are tangled up, and if you've ever seen a hockey fight, then you know that however they're moving, good enough. However they're moving, they're going to move together. Now, are they going to slide to the right? Are they going to slide to the left? I don't know, but the sign of the answer is going to let me know. If I get a positive velocity, since I'm choosing that to the right is positive, if I get a positive velocity for my answer, then I'll know that they're sliding to the right. And if I get a negative velocity for my answer, I'll know that they're sliding to the left. So I'm going to use the law of conservation of momentum now that I've got this drawn out, and I'm going to work a little bit with some numbers now. So from reading the question, I know that the Mighty Duck player had a mass of 40 kilograms times 4 meters per second, and that was positive. So the Mighty Ducks' momentum before they run into each other, that's a positive velocity. And the player from the other team has a momentum of, the mass is 50 kilograms times a velocity of negative 3 meters per second. And it's really important that we use negative 3 meters per second there, because that comes down to the difference between adding and subtracting. And that would give us a very different result in the end. So here, 40 times positive 4, that's going to be 160. And the units, kilograms times meters per second, 160 kilogram meters per second, plus 50 times negative 3, that's going to be minus, that's going to be negative. I'll just change my sign right here. So the Mighty Ducks player had positive 160 kilogram meters per second of momentum, and the player from the other team had a momentum of negative 150 kilogram meters per second. And now you can see here why making sure that we get our signs right is so important, because if I had missed this negative sign here, then I'd be doing 160 plus 150. That's 310, and that's definitely different from 160 minus 150. The total momentum that these two have is just 10 kilogram meters per second. So I hope you can see how we would get definitely a wrong number for how much total momentum if we had missed putting the negative sign there. And that's part of why I choose to draw this out before I do anything else. Now, I've done everything I can do for the left side of this equation for before they collide. So let's think about momentum after they collide. Remember, the key point here is that the total amount of momentum of these two skaters doesn't change. That's why this question happens on ice, so we can ignore whatever effects from friction. And so the total momentum of these two before they collide equals the total momentum after they collide. Now, after they collide, I've got 40 kilograms and 50 kilograms. I've got 90 kilograms worth of hockey player. (40 plus 50), and they're both moving together. So whatever velocity the blue player here has, the red player has to have the exact same velocity, because if not, well then they wouldn't be all tangled up and moving together, and that was the question that I had. So I've got 90 kilograms worth of mass moving with some unknown velocity, and I know that the total momentum, 90 kilograms times velocity, has to equal the total that I had from my left side. So here I'll just jump down here. 90 kilograms total times that velocity is equal to the total momentum of our system of that pair of players was just 10 kilogram meters per second. So now if I wanted to know how fast, then I just need to get this v all alone, so I'm going to divide both sides by the 90 kilograms. Now when I do 10 kilogram meters per second divided by 90 kilograms, that's going to give me my velocity. Now, if you pay attention to the units, kilograms on top, kilograms on the bottom, the kilograms are going to divide out, and the unit I'm going to be left with is just the meters per second, and that's 10 over 90. 10 over 90 is 1/9, and if you can put it in your calculator if you don't believe me, but that's going to be 0.11 meters per second is that velocity. Now, I calculated a positive number there, and since that's a positive number, then thinking back to the beginning of the question, when I set up my positive direction, I said positive is going to the right, and since I got a positive answer, that means that this pair of hockey players is sliding to the right.